At the back of the electrical motor, we see that the fan is connected to the shaft. When the motor rotates the shaft, the fan will therefore also rotate. The fan is used to cool down the electrical motor, and it will blow ambient air over the casing to dissipate the unwanted heat. If the motor becomes too hot, the insulation on the coils inside the motor will melt, causing the motor to short circuit and destroy itself. The fins on the outside perimeter of the casing increase the surface area of the casing, which allows us to remove more unwanted heat. The electrical motor comes in either 3-phase or single-phase configuration, depending on the application. We're going to look at 3-phase as this is the most common. Inside the 3-phase induction motor, we have 3 separated coils which are wound around the stator. Each coil set is connected to a different phase to produce a rotating magnetic field. When we pass AC or alternating current through each coil, the coil will produce an electromagnetic field which changes in intensity as well as polarity as the electrons passing through it change direction between forwards and backwards. But if we connect each coil to a different phase, then the electrons will change direction between forwards and backwards at a different time compared to the other phases. This means that the magnetic field of each coil will change in intensity as well as polarity at a different time compared to the other phases. To distribute this magnetic field, we rotate the coils 120 degrees from the previous phase and insert them into the stator of the motor casing. This will create the effect of a rotating magnetic field. At the center of the stator, we place the rotor and shaft. The rotor will be affected by the rotating magnetic field and will force it to also rotate. The rotor is connected to the shaft, and the shaft runs from the fan through the rotor all the way up to the impeller. This way, when the rotor rotates, so will the impeller. So now, by creating the rotating magnetic field within the motor, we spin the rotor, which spins the shaft, and this spins the impeller.